Welcome. Hello, welcome to this session. And I'm Tony, and another speaker is Leon. We are the team from the QCT. And today we would like to talk about our on and off premise solution validation on code. So, what is our motivation? Our motivation can be briefly divided into two perspectives, from the hardware perspective and from the software perspective. And from the hardware perspective, hardware from the different vendors may not compatible with each other. Also, the heterogeneous hardware will also increase the deployment effort. And from the software perspective, deployment of code takes a lot of time, as you know, and also every new commit may affect the existing hardware. So that is why we developed the solution so-called QCT Code Ready Path, as Dr. Kate mentioned in the previous session. So in order to achieve our on and off premise solution, our goal beings from solution deployment and the validation process to become automatic and portable. So in this slide, we will show a brief that what have QCT added on in code platform. So first, we have the on and off premise CI/CD service. And the second is the code 6.0 auto deployment. And the third one is the system validation. Next, in order to test the integration of the overall environment, we have onboarded some types of VNFs. The first one is EPC software provided by R3. And the second one is the QCT service assurance, which is also presented by Dr. K in the previous session. QCT service assurance will provide the monitoring as a service in the core environment. So why it matters? Simply, we are trying to keep our deployment up to date. So this can make sure our hardware is always compliant with the latest code. And the second reason is the manual works are not possible for the daily deployment. Since it will take a lot of time to do the deployment each time. And the third reason is because there's customer side validation. We need to do the conformance test at the customer side when we ship the product to the customer. So this is will require the portability. And the last reason is because based on what QCT done, we can easily accelerate the partnership collaborations. Okay, here is the reference architecture of our QCT Code Ready Path. There are 5 switches and 4 servers. The 4 servers in this architecture. 1 switch for management, 4 switches for the code fabric, and 4 servers for providing the computing resource. Briefly, we will use 3 tests to do the validation in this environment. The first is the switch conformance test, and it will use to test the physical switch. The second is the system test, which will test the status of core services. And the third one is the integration test to test the status of the overall environment. Next, we will describe the procedures of each test. For the switch conformance test, we have selected our QCT IX1 100G switches to do the deployment to do the integration for code fabric. Actually, we have already integrated this model with Core 5.0. Since the Core 6.0, the architecture of Core 6.0 are changed, we have need to do some change to make our switch to being able to deploy with the Core 6.4. So in our environment, we based on M-Code 6.0 to do the integration. But in this version, there is one missing part need to be fixed, which is the Fabric services is not deployed by default. So there is only one ONF deployed for controlling OBS, which is provide the VDN service. So in order to integrate the hardware switch into M-Code 6.0, we have done two things to make it happen. The first is we have collaborated and consult with the community to come out a draft of our switch certification testing process. And the second one is to change some Tosca files in the ham service to include the Fabric service. So after these two processes are done, the Fabric service will be allowed to deploy it with code. So talking about the switch certification testing process, this process is briefly divided into 3 steps. Step 1 is to use Fabric OF test to do the conformance test with 3 switch. And this test will make sure the features required by the core environment it's supported on the physical switches. And the second is the connect for physical switch as leaf-spine architecture, then use ONF to test the segment routing integration test. This test is including 4 test cases: on-tag VLAN bridging, single VLAN bridging, double VLAN bridging, and the routing with MPLS. So the step 3 is to modify some Tosca file we mentioned in previous slide to make the physical switch being able deployed within code. So after you done these 3 steps on the physical switch, your switch will be allowed to deploy it with code. And for the system test, we use code test to do to test the code, the status of code services. And code test is developed and provided by ONF community, and it is an extensible end-to-end system testing suite targeting for core part. So currently, our system test cases include postal installation test and XOS-based test. More test cases will be included in the future. Next, talking about the integration test, we have mentioned that we already onboard some types of VNFs. The first one is the EPC software provided by Archie, and this EPC software is divided into 2 parts: EPC control plane and the EPC data plane. And the second is the packaging VNF for simulating the GTP traffic. And the third one is the QCT service assurance, which is composed by 4 VNFs. Here is the system architecture of the QCT code ready part. So you can see there are 4 switches connect as leaf-spine architecture for providing the underlay network connectivity, and the OBSs on each service will provide the overlay network connectivity. So after these VNFs are successfully onboarded, they can be deployed in this environment, which such as Archie EPC control plane and data plane, packaging VNF, and also the 4 VNFs for the QCT service assurance. So here is the high-level architecture on XOS GUI. As you know, this picture shows the relationship between each component. So, So the components inside the blue rectangle are the EPC control plane and the data plane, and the component inside the green rectangles are the packaging VNF. Also, the components inside the orange rectangles are the QCT service assurance. So we can see the instances that are successfully created on core environment. There are totally 7 there are totally 7 services are created in this environment. So after these services are successfully running on the in the environment, so next we will use packaging to do the integration test. Here we are going to show a network topology between each VNF. So EPC control plane will provide the features such as HSS, MME, S gateway control plane, and the data P gateway control plane. And EPC DP will provide the S gateway data plane and the P gateway data plane. So the EPC data CP and DP will connect to each other with the S1 MME and S11 interfaces. Then connect to QCT service assurance with management interface. Then our package, the packaging VNF will connect to the EPCDP with S1U and SGR interfaces. Next, the next step is to use packaging to generate the uplink and the downlink traffic to pass through the EPC services. So here's a screenshot captured on the packaging VNFs that as you can see, the result shows the traffic of uplink and the downlink are successfully passed through the EPC service. So this proves that the status of integration on this environment is fine. So we can also see the system status on QCT service assurance web GUI. The left side shows the OpenStack service status, and the left side shows the physical hardware resource utilization. Also, we can use the service assurance to monitoring the stats of the EPC service running on code. So as you can see, here's are the uplink and the downlink throughput that pass through the EPC services. So let's move to the automation part details.
Hi, I'm Leon. I'm the solution DevOps engineers in QCT. In the later part of this presentation, I will talk about the automation and the validation details of this project. About what we have done in QCT. Okay, first, we are going to talk about automation tool stack we are using. Currently, the tool stack is pretty simple. In the Core 5 era, we use Jenkins on OpenShift as the CI service, or CI server. But in the Core 6 era, we give up Jenkins and use Drone to replace it. And I will explain why later. And we also use Ansible as a configuration tool. Why Drone? Drone is written by Golang, so it just need very small amount of resource to use it. And the Docker is the only dependency. You don't have to install any other software except Docker. Deployment as code. That means if you want to make a Drone CI server up and running, the only thing you need is a is a Docker compose file. That means you can save all the configuration of the Drone server in the file and then make it version control. Docker in Docker. That means you can define different Docker images in different tasks in the automation pipeline. That means you are not limited in the environment that the Drone CI server stayed in. Portable. In order to achieve on and off premise solution validation, that means we have to do this identical validation and the test processes in the customer side as we did in the QCT lab. So portable is a very important feature to us. Why Ansible? First, agentless is really important because you don't have to install any agent in the remote server you need to control. Second, it's capable to configure multiple machines simultaneously. It's a very efficient configuration tool. And the Ansible playbook is written by YAML syntax, so it's much human readable than pure shell script. Modularized design. Ansible has a lot of existing powerful modules can be used and leveraged. You don't have to build your own wheel. You just leverage them. And if you have to, you can just write your own module, and there's no problem with that. This is a picture of the code deployment flow overview. In the QCT lab, we have 3 environments: Vert, Dev, and SIT respectively. In the Vert environment, as its name implies, there are only virtual machines inside. So once the deployment and the tests are done, it will trigger the dev to start. In the dev environment, it's almost identical to the Vert environment. The only difference is the virtual machines are replaced by bare metal servers. And once the deployment and the tests are done, it will trigger SIT to start. In the SIT environment, besides bare metal servers, we also have QCT IX1 100G switch inside. So after deployed the code, we also do the switch integration and the test as well. And then once all the jobs are done, we will send a notification to the Slack channel to notify the administrators. This is our code deployment process detail. Because we do everything from scratch, so we start from provisioning OS, then install Kubernetes, then install OpenStack, install core, then physical switch integration and the connectivity test. Finally, we run some code tests to do the test and VNF onboarding to do the validation. There's one thing you need to notice is the second one. If you install the Kubernetes by yourself, instead of using OpenStack ham infra to install a Git-based Kubernetes, you will hit a lot of snag. So here I have some troubleshooting experience I want to share. OpenStack ham installation starts occasionally. We fixed this issue by building a local registry mirror with Harbor to fix that. For making sure all the Docker images are pulled from local instead of Docker Hub via internet. External name doesn't work. Okay, when you are deploying the core, you have to create some Kubernetes service with external name type. But external name type only works with kubeDNS, not core DNS. So if you install the Kubernetes by yourself, you have to make sure the DNS service on the Kubernetes is kubeDNS, not core DNS. And some OpenStack services are not scheduled and working properly. There are 2 things you need to do to fix the issue. First, you need to remove the tagged attributes from all the method node. Because the tagged attribute make all the workload are not be able to schedule on it. And you have to configure the correct label set on the Kubernetes node to make the OpenStack service can schedule on it. But you don't have to but the label set information is not well documented on the OpenStack project side. So you need to install the Git-based Kubernetes at first and get the information from it. Cannot mount volumes from safe RBD. Okay, when you install the OpenStack on the Kubernetes, Safe is the first service to be installed on the Kubernetes. Then the rest of the service will use Safe RBD volume as the backend storage. But at this time, Kubernetes cluster has no capability to mount Safe RBD volume. So you have to do some hacks to make it happen. First, you have to install Safe RBD client in every node in the Kubernetes cluster. Second, you have to copy the safe.conf from the safe manager part and put it inside into every node in the Kubernetes cluster. Finally, code tester crash Kubernetes. It's a really weird problem. Okay, if you install the code tester in any node of the Kubernetes cluster, it will crash the kubeDNS service. For the time being, I haven't figured out what's the root cause, so I just move the code tester to the outside VM to fix the issue. And there are two more features. The first one is Robach, and second one is API test summary consolidation. Basically, the idea of the Robach is pretty simple. If the deployment is successfully down, the version information of every repository will be saved into the external etcd service. But once it failed, the automation process will trigger drone to do a rollback deployment. In the rollback deployment, the automation process will get the latest successful build information from the external etcd service and pull the specific commit of every repository to do the deployment. So that's how the rollback do. Test summary consolidation. If you run a test with a code tester against the code path deployment, in the test it will generate several files, including logs and the testing results, several files. If you run multiple tests, it will generate a bunch of files. It's not easy to read and browse. So we wrote a program to consolidate these files into a summary page. It's much easier to read, and by click the links on the summary page, you can also browse the details about every test. In order to make our code deployment up to date, we do including the code path itself and the underlying infrastructure, we do the daily deployment against the latest code of every repository that I mentioned before. That I mentioned here. Okay, yeah, mentioned here. Okay. So far, Kubernetes, we are using 1.12.3. It's the latest version of the stable release. And as for the OpenStack ham and the OpenStack ham infra, we do the deployment against the master branch code. But we still stick, as for the open core ham chart, this project, we still stick in the branch core 6 because we did some modification for doing the physical switch integration. So keep code path deployment up to date is our first future plan. So that means we want to make our code path deployment against the master branch of every repository that I mentioned before. Second, I want to replace the daily deployment with a git watch trigger. So I won't like to do the daily deployment again. I will try to keep monitoring the repository that I listed before. And if any new commit is pushed, the deployment process will trigger automatically against the latest code. And I want to add, and we will deep dive into the code tester and add more and more tests into our deployment process. And then we also want to collaborate with other VNF providers and try to onboard more and more VNF on our code deployment and validate it. Okay.
Okay, here comes the summary. So, Curiosity provides us one-stop shop service for the code environment, and as we come out a draft of the switch certification testing process, this process can be more mature by working with the code certification brigade. And based on what QCT done, we can easily accelerate the partnership collaborations to evaluate their VNFs on code. And also, as we have onboarded some EPC VNFs, the integration of the physical RAM for more complete end-to-end use case is under the plan. So, from an automation perspective, automations help us have a great saving time and effort for deployment. Also, developers can focus on things that are truly important. And also, it can accelerate the test and the validation. And the last thing is that the portable automation does matter for our client. Oh, I have to, as you know, QCD is going to hold the NGCO launch event on Thursday, January 24th, 2019. So we're pleased to invite you to join us. The topic range are including 4G, 5G, and VRAM, the VNF accelerating by FPGA P4 to the NFVI reliability testing. So please register your attendance with the GUE 19. So thanks for your attention. Any questions?
Are there any questions? Already, we're running quite a ways ahead. We're about 5-10 minutes ahead of time. So I think we'll have a really short break and start the next, because I don't want to start the next talk before people who might be wanting to come to it will go there. But thank you, Tony Liam.
Thank you.
Thank you.